Right now, in some corporate office somewhere, an executive is looking at a beautifully designed dashboard showing a 100% compliance pass rate.
Yeah, a perfect green screen.
Exactly. And they feel perfectly safe.
Hmm.
But they are completely wrong. Welcome to the Deep Dive. I'm your host, and today we're looking at how AI is stepping in to basically kill the annual evidence panic.
And I'm the resident expert today, and we'll also be talking about why trusting that AI blindly might actually be the most dangerous thing a business can do right now.
Yeah, it's a huge topic. So just to give you an overview of where we're pulling this from, we've got two really incredibly detailed pieces published on the GRC PROS blog.
Right, from back in June of 2026.
Yeah, authored by GRC consultant Alex Seven. And the whole focus here is this massive shift in governance, risk, and compliance, moving away from manual control testing and moving toward, well, AI-assisted assurance.
Which is such a necessary shift. I mean, the mission of our deep dive today is to really explore how AI is ending that era of manual screenshot chasing, you know?
Oh, absolutely.
But also clarifying why the future of GRC isn't about letting AI just do everything for you. It's really about keeping humans in the loop to get true risk intelligence.
Right. So grab a coffee, settle in, because we are going to untangle this whole mess. Let's get right into it.
Sounds good.
If you work in this space, you know the annual evidence panic intimately. It's that visceral, frantic scramble at the end of the quarter or the end of the year.
Oh, yeah, the worst week of the year.
Truly. Suddenly, half the company's running around with their hair on fire, digging through old folders, taking desperate screenshots of configuration pages, just hunting down 6-month-old chat logs.
Just to prove to an auditor that security jobs were actually being done months ago?
Exactly. It's like doing a whole year's worth of homework the night before it's due. I mean, sure, it might get you a passing grade from the teacher, but it doesn't mean you actually learned the material, right?
No, not at all.
Or in this case, it doesn't mean you actually reduced any risk.
Yeah, it's a super painful ritual. And honestly, the sheer administrative burden of it is just burning people out.
Oh, totally.
But if we look at the mechanics of why we actually do this, the traditional point-in-time testing model, it was actually perfectly logical for the world it was originally designed for.
Right, like 10 or 15 years ago.
Exactly. We used to operate in these highly stable, centralized tech environments. You had a monolithic server stack, very slow, predictable release cycles. I mean, the IT department updated systems maybe, once a month?
If that. Sometimes once a quarter.
Right. So checking your controls once a year actually made sense because the environment fundamentally looked the same in December as it did back in January.
But that world is dead.
Completely dead.
I mean, today you are dealing with continuous cloud shifts, rapid software as a service deployments, APIs connecting literally every app to every other app.
And CI/CD pipelines.
Yes.
Yeah.
Where developers are pushing new code to production like multiple times a day.
Yeah, the ground is just constantly shifting beneath your feet. A control that worked flawlessly yesterday might be completely broken today just because a cloud logging setting got bumped during a late-night deployment.
Right.
Or maybe a developer spun up a new privileged database account for a quick patch and just forgot to delete it.
Which happens all the time.
All the time. Or one of your core vendors flips on a new machine learning feature without even notifying you, and suddenly how your customer data is processed is completely different.
Yeah, so if you're only testing manually once a year, you are completely blind to those micro changes for months. The whole purpose of testing has just become so warped.
Yeah, we've basically been culturally conditioned to think the ultimate goal of compliance is to just create a neat little folder of artifacts to hand over to an auditor.
Yeah.
But chasing screenshots to make an auditor happy isn't risk management, it's paperwork management.
Okay, let's unpack this a bit. Because if the problem is that human speed simply cannot keep up with cloud speed, why are we jumping straight to AI? I mean, we've had automated scripting for years, right?
Yeah.
If a cloud environment changes every minute, couldn't you just write a script to check the configuration every minute?
Well, automation is incredibly valuable, don't get me wrong, but it has a very hard ceiling because it's fundamentally rules-based. It requires perfectly structured data.
Okay.
So if you want to check a binary state, like, is multi-factor authentication enabled on this specific server instance? Automation is the perfect tool for the job. True or false, 1 or 0.
Right, it's like a light switch.
Exactly. But a modern compliance environment is not a fuse box. It is full of unstructured data, behavioral nuance, and just massive amounts of gray area. GRC relies heavily on interpreting human actions.
Which is where traditional automation just sort of breaks down and AI thrives, right?
King.
Take a vendor SOC2 report, for example, for those who haven't had the pleasure. SOC2 is this massive independent security audit that every major vendor hands over to prove they're safe to work with.
And they are painfully long.
Oh, they're awful. There are often over 100 pages of dense legal and technical jargon. An automation script cannot read a PDF and determine if the vendor's subservice exception clause introduces unacceptable risk to your specific supply chain.
Right, but an AI can. An AI can digest that unstructured text, synthesize the context, and flag the exact paragraph you need to worry about. It can read through, hundreds of change records written by different developers in their own shorthand.
With all their weird typos and inside jokes.
Exactly, and the AI can actually understand the intent behind the ticket. And what's fascinating here is how this leads to the concept of mismatched evidence.
Oh, yeah. That really shifts how you think about control failures. Because we normally tend to assume that when a compliance check fails, it's because someone just forgot to do the task.
Right, like the evidence just simply does not exist.
Yeah. But mismatched evidence flips that assumption entirely. The control failure isn't a lack of evidence. It's evidence that exists but completely fails to prove the actual intent of the control.
Yeah, let's ground that in a concrete example so it's really clear. Say your policy requires that all employee system access is reviewed quarterly by a department manager.
Pretty standard stuff.
Right. So the IT owner runs an export from your identity system, saves it as a massive CSV file, names it Quarterly Access Review Q3, and uploads it to the compliance portal.
Okay, so a traditional automation script sees that file upload, verifies the file name matches the expected format, checks the timestamp, and just gives the control a green passing grade.
Yep, the evidence exists.
But the AI opens the file and realizes the context is completely missing. It sees a list of thousands of users, but the document doesn't show who actually performed the review.
Exactly.
It doesn't include a sign-off date. And most importantly, it doesn't show that any inappropriate access was actually revoked as a result of that review. So the evidence is technically there, but it's mismatched to the real requirement.
Right. And a human analyst would absolutely catch that mismatch eventually, but it might take them, 3 hours of cross-referencing pivot tables on a Friday afternoon.
Ugh, sounds miserable.
It is. But the AI catches that contextual mismatch in milliseconds.
Okay, wait, hold on, though. This sounds like a magic bullet, but what about the garbage in, garbage out problem?
Ah, yes.
Like if I feed an AI a terribly written, vague control, something like employee access is reviewed sometimes, won't the AI just look at a single Slack message saying, looks good, say, yep, that counts as sometimes, and give us a green light?
It absolutely will.
Which actually seems way more dangerous than doing it manually, because now we have this highly advanced machine basically giving us mathematical permission to be lazy.
And this raises an important question, right? Because that is the exact danger zone these sources highlight. It's a trap a lot of early adopters are falling into. AI is a powerful interpretation engine, but it absolutely cannot fix bad control design.
Right.
It will confidently execute whatever flawed logic you give it.
Because it has zero inherent business context.
None at all. Think about a missed security patch. To an AI, a failed patch is just a failed patch. It's sort of like a spell checker.
Okay, I like that analogy.
A spell checker knows you spelled a word incorrectly, but it has no idea if you're writing a casual grocery list or a legally binding multi-million-dollar contract.
It just sees a typo.
Right. It lacks the broader context to weigh the real severity of the error. So the AI sees a server missing a patch and flags it as a failure. But it doesn't understand that the server is an isolated internal test sandbox containing zero sensitive data.
Right. Whereas another mispatch might be on your core production database holding heavily regulated financial records.
Exactly. And this leads directly to the most terrifying phrase for any risk professional: false assurance.
Going back to our executive looking at that green dashboard from the intro.
Yes. False assurance is when an AI-generated compliance dashboard looks polished, authoritative, and perfectly green. It confidently tells the board of directors that everything is passing. The executives believe a critical risk is fully mitigated, when in reality, the AI just completely missed the nuance of a weak control design, or failed to understand the business context of a critical system.
So false assurance is significantly worse than having no assurance at all,
Mm-hmm.
because you are confidently driving toward a cliff while your GPS swears the road is clear.
That's exactly it.
You can't just plug an AI into your compliance software, fire your audit team, and go grab a coffee.
Mm.
You need a structured framework to harness the speed of the machine while keeping human judgment strictly accountable for the actual risk.
Right, and to prevent that false assurance, the sources outline a really specific operating model to keep the human in the loop.
Let's walk through that.
Sure, and it actually starts long before the AI ever looks at a piece of evidence. The first step is entirely human. You have to fix your own sloppy control designs. You have to ensure your controls are explicitly testable.
So, if your policy just says, access is reviewed periodically, you have to change it to something like, access is reviewed every 90 days by a director-level manager or above with documented sign-off.
You're right.
You have to give the AI a rigid rubric to judge against.
Step 2, you also have to classify suitability, because not everything should be handed over to an algorithm.
Like what?
Well, assessing whether an executive's formal risk acceptance is sufficient for the board of directors that requires nuanced human political and business judgment. AI should not be making those calls.
That makes total sense. And step 3 is defining those evidence standards we just talked about. But then, once you establish that foundation, you reach step 4, which is the core mechanism of the whole framework. Using AI to pre-test, not final test.
Yes, pre-testing is key.
The AI does the heavy lifting, acting as this ultra-fast, first-pass reviewer to flag anomalies, treating the AI as a preliminary filter rather than the final judge.
Exactly.
It's kind of like getting a complex medical lab test. You give your blood to the clinic, and this highly sophisticated million-dollar machine processes the sample.
Right.
It flags anomalies, say, high cholesterol or a weird enzyme level. But that machine does not print out a prescription and hand it to you.
Thank goodness.
Yeah, the human in the loop, looks at the machine's output, considers your family history, asks about your diet, and then delivers the actual diagnosis and treatment plan. That's step 5.
That's a perfect analogy. The AI is the lab machine processing the data at massive scale. The GRC professional is the doctor interpreting the results. The human steps in to handle exceptions, investigate failed controls, and make those high-risk judgments based on that first pass.
And crucially, moving to step 6, you have to preserve the record of that interaction, because external auditors are still going to show up.
Oh, they definitely are.
And when they do, you cannot just say, well, the computer said it was fine.
No auditor is going to accept that.
Right. You need a documented trail showing exactly what data the AI reviewed, what anomalies it flagged, and why the human analyst made the final determination they did.
Which brings us to step 7. You're essentially auditing the AI itself, right? Monitoring the governance tool to ensure it isn't hallucinating compliance or slowly drifting from your evidence standards over time.
Right. So here's where it gets really interesting, because to really understand how this friction plays out, we need to look at real-world application. The sources actually detail a pilot program at a mid-sized B2B SaaS company that implemented this human-in-the-loop model.
Yeah, this is fascinating.
Let's look at their first major use case, access reviews.
So anyone in IT knows access reviews are a complete manual nightmare. This particular company was spending hundreds of hours cross-referencing lists to ensure terminated employees were actually locked out.
Ugh, soul-crushing work.
It really is. And checking that the correct managers were approving access across this sprawling web of applications, Okta, AWS, GitHub, Jira.
Staring at thousands of rows on a spreadsheet on a Friday afternoon. I mean, human error is basically guaranteed at that point.
Absolutely.
So they unleash the AI to do the pretest. The AI ingests the entire evidence package and immediately flags an AWS account belonging to a former contractor. It notices the contractor's termination date in the HR system was 2 weeks before the access review, yet their cloud access was still active.
A glaring red flag that a manual sampler might have completely missed if that user wasn't in the, random 10% of rows they check.
Exactly. But then the AI catches something incredibly subtle. The identity provider review in Okta was actually completed on time, but the AI correlates the reviewer's name against the HR organizational chart.
Which a human would almost never have time to do line by line.
Right, and it catches that one of the managers was approving access for users who were outside of their actual reporting line.
That is the real power of AI correlation right there. But this is also where step 5, that human review, becomes so critical. Because during this same scan, the AI flagged a Jira administrator who retained elevated administrative access even after transferring to a completely different department.
And to the AI's strict logic, Department change equals immediate loss of previous admin rights. It just flags it as a hard control failure.
But the human analyst investigates the anomaly and uncovers the business context the AI lacked. The user retained that elevated access because they were actively supporting a critical temporary data migration project between the two departments.
Ah, I see.
Yeah, so it wasn't a mistake. It was a highly specific, valid business need.
However, the human analyst also discovers there was no documented exception approval for this arrangement.
Right, so the human concludes it's not a failure of the access removal process itself, but rather a documentation and exception management failure.
The AI found the anomaly, but only the human doctor could diagnose the actual root cause and assign the correct remediation ticket.
Exactly.
Let's look at the second real-world use case they piloted: vulnerability management SLAs.
Okay.
A service-level agreement in this context is a strict internal deadline to fix a security flaw. So their policy mandated that critical vulnerabilities must be patched within 15 days and high-severity ones within 30 days.
And traditionally, testing a control like this is heavily sample-based. An auditor just asks for a random selection of 25 JIRA tickets from the quarter, checks the timestamps, and just sort of hopes those 25 tickets accurately represent the thousands of changes happening across the entire company.
Which is a terrible way to measure actual risk because you are willfully ignoring 95% of your environment.
Yeah.
But with AI processing power, they dropped the sampling entirely. They fed the entire population of data, every single vulnerability scanner export, and every single JIRA ticket directly into the AI.
And the AI maps the unique identifier for each vulnerability from the raw security scanner directly against the status of the corresponding JIRA ticket.
And the results were wild. The AI flagged 3 critical vulnerabilities that had blown past the 15-day SLA. But more importantly, it spotted this terrifying disconnect. 2 high-severity vulnerabilities were marked as closed and remediated by the developers in the JIRA ticketing system. But the raw security scanner data showed those exact same vulnerabilities were still actively exploitable.
Oh, wow. Yeah, this is a classic organizational blind spot. A manual reviewer or even a basic automation script looking just at the JIRA system would say, great, the ticket is closed, the control is operating effectively.
But the human analyst steps in to investigate the AI's mismatch alert, and they uncover the actual mechanism of the failure. The developers did write the patch, and they did deploy it, but they only deployed it to the staging environment.
Oh, no.
Yeah, they never pushed the patch to production.
So the administrative ticket gets closed, satisfying the paperwork requirement, but the actual real-world risk is still sitting out there, completely exposed to the internet.
The AI caught the mismatch between the paperwork and the reality. But again, human judgment proved essential because during this same massive scan, the AI threw a severe red alert about a critical vulnerability missing its 15-day window.
Right. And when the human security engineers reviewed the alert, they realized the vulnerability scanner was just generating a false positive based on a misidentified software version. The risk didn't actually exist at all.
Right? If the AI was authorized to be the final boss, it would have failed the control, generated an executive breach alert, and sent the entire engineering team into a weekend panic over a ghost.
Yeah, it's a brilliant assistant, but a really dangerous authority figure.
So what does this all mean for the people actually doing this work?
Well, if we connect this to the bigger picture, looking at the trajectory of this technology, it signals a profound psychological and operational evolution for the GRC professional. I mean, there's widespread anxiety that AI is coming to eliminate compliance jobs, replacing analysts with algorithms.
Yeah, you hear that everywhere.
You do.
Yeah.
But the underlying argument of this transition is the exact opposite. AI isn't replacing the GRC professional. It's elevating the role by stripping away all that administrative drudgery.
Oh, absolutely.
Practitioners are moving away from being these administrative screenshot chasers who spend their weeks checking basic boxes, formatting spreadsheets, and begging engineers for evidence artifacts.
Because the AI takes over the heavy lifting of data correlation and anomaly detection.
Right. And the human is freed up to become a high-value risk analyst.
They actually get to spend their cognitive energy designing more resilient control architectures, assessing the business impact of complex policy exceptions, and translating their raw technical anomalies into actual risk narratives for the executive board.
It requires vastly stronger judgment and way deeper business acumen, because at the end of the day, the goal of compliance testing isn't to prove that a piece of evidence exists in a digital folder somewhere.
No. The goal is to prove definitively that your controls actually work and protect the company from real threats.
Exactly.
Defending that standard is going to become the primary mandate for GRC teams as AI integrates permanently into the assurance process. This is a massive paradigm shift, and honestly, it is about time we stopped doing a year's worth of homework the night before the audit.
Preach. It really is.
But I want to leave you, the listener, with one final thought to mull over. We've spent this entire deep dive examining how humans can use AI to audit human-built systems. But as we look just 2 or 3 years down the line, what happens when the operational systems generating the evidence are also fully autonomous AIs?
Oh, man.
Right? If an AI is dynamically spinning up infrastructure,
Hmm.
writing its own code, and altering configurations in real time based on machine learning optimizations, will we reach a point where our GRC AI is essentially cross-examining an operational AI?
That's a wild thought.
And if we hit that point, how does a human auditor even begin to untangle a debate between two machine logic systems arguing over what constitutes an acceptable level of risk? Think about that the next time you feel the annual evidence panic creeping in.